jobs. Some fields are even packed with bit flags, with decimals and custom encodings also that the newer systems don't handle even natively. So if you see that, uh, so over the data that is broadly classified and broadly detailed with other factors. So newer systems that is not involving those types natively, and over the time extra fields that also squeezed into bytes, spare bytes, or even repurposed in a way that are not fully documented. So, in fact, when you move off COBOL, you need to decode and you need to accurately map every one of these fields into the new structure. And when we talk about new structure, that is even the JSON or relatable relational tables or even the modern formats also without breaking any existing logic. And that's also taking task. The fourth is the strong independence in interdependencies that is between the batch and the online systems. So online programs create and update the records that are later picked up by the job batch. So uh, by the batch jobs basically. So in many enterprise, the online systems like CICS transactions, APIs, and the batch jobs are deeply intervened. So batch jobs overnight restructure the data, regenerate the balances, or produce the summary table that the online systems depend on the next day. And sometimes online processing even pauses while certain batch steps in. So this means that if you are moving or rewriting one part, let's say a batch job, you have to be sure that all online pieces that depend on its output will still be working correctly. Those cross dependencies make the phased replacement more complicated and high regression risk when migrating or rewriting. So, because of the size, the coupling, and complexity, any changes that carries a high regression risk, and the risk that something which is used to work will quietly stop working, right? So there may be edge cases that only occurs once a year, right? And only for certain customers, only for certain products, maybe. So that basically, as a result, the team has to invest heavily in parallel runs and validations, which makes a large scale replacement expensive and slow. So that is the reason here. So basically, when someone says that just rewrite the code in Java, or let's say move it to the cloud, these are the areas that needs to be carefully strategized, basically. So as we see that rounding differences, data handling, cutoff times, which can be unacceptable in financial or regulatory environments. So, as a result, teams have to invest heavily in testing or validation or in parallel runs, which makes the large scale replacement expensive and slow as well. So, that is the part that technically what will be the challenges and what makes COBOL hard to replace technically. In the next slide, this is about the business side. So in the previous slide we saw about the technical constraints. Now in this slide focuses on the business realities that shape the modernization decisions. So even if the technology is ready, these business factors also influence what can actually be done. The first, as you see here, is the high cost and the duration of transformation programs. Since replacing a major COBOL system is not a 3-month project, it's often a multi year transformation that involves hundreds of people. Like you need analysis, you need design, development, intensive testing, dual running, data migrations, training, and change management. And during that time, you are effectively paying twice. You still have to maintain the existing COBOL system and also have to fund the new build. services works or interest calculations or interest related calculations works. So those people are often in short supply, and many are in the age of almost retirement as well. So with that, with newer staff may not have been trained on these systems. So that scarcity becomes a bottleneck. That there are only so many experts available to review the requirements, validate the rules, and sign off with a new implementation. So that's become like a challenge. So that is one. And finally, competing the priorities for budget and attention, which is at the executive level. The modernization is just one item in a long list of priorities. Launching new digital products, improving the cybersecurity, expanding into new markets. So even everyone agrees to that the whole state should be modernized. It's competing for some same pot of money basically in leadership focus. So as a result, many organizations decide to be stabilized and wrap that they have, for example, by exposing core functions as APIs and then modernize selectively where it delivers clear values, business values. So basically, when we ask why COBOL is still here, so the answer is just not technical, but is also about the cost and the length of large programs, the operational and the reputational risk of failures, the limited expert capacity, the regulatory obligations, and competing strategic priorities also. So understanding these business constraints help us design modernization strategies that are realistic, like start with high value, lower risk slices, prove success, and then build momentum with rather than proposing all or nothing replacement basically. So that's the side of the business. And that is the next part is that is to understand, which is from rip and replace to modernize and integrate. So since we have already talked about why COBOL is still around and why it is still hard to replace technically and with business aspect, this slide basically explains that reality. It changes the strategies organization use. So historically, people first talk about getting rid of COBOL. The instinct was rip and replace. Let's throw away the old mainframe system and rebuild everything, let's say in Java, in .NET, in cloud. So that was the old saying basically. But in practice, we learned that completely rewriting are rare and risky, and they take many years also. Also, requirements drift while the new system is being built. So by the time you already go live, maybe the business and the regulations can also have some changes again. And then by when you finally cut over, so there is a real risk of discovering the missing edges cases in productions. So because of these experiences, most mature organizations have moved away from the big bang, rip and replace, and especially for the core COBOL systems. Instead, more organizations chooses the phased modernization. That is, keep the business running, improve the architecture step by step, and reduce the risk at the each stage. So you don't eat the elephant in one bite, you slice it into smaller, value driven pieces. And that start with a contained domain or the product line. Then modernize that successfully, prove the benefits, then extend the approach. So the key pattern is approach is to wrap COBOL with the APIs and integration layers, and that's why we add this as a title as that modernize and integrate. That is instead of replace, basically. So the pattern is to wrap COBOL with APIs. You treat the existing COBOL programs as services instead of the old monoliths in the basement. Using the tools and the integration platforms, you expose specific transactions like calculate premium. You add get balance as the REST or the SOAP APIs. So one of those APIs exists. The modern front-end or microservices or cloud apps can tell or call them without carrying the logic underneath Escobol. So this is basically this buys you two things. You can deliver new digital features quickly, as well as you can create a clear, well defined boundaries around the pieces of COBOL functionally, and which later makes it easier to replace those pieces. Another pattern is to rehost or refactor the parts of the workload. So rehosting means moving the COBOL workloads from a traditional mainframe system to another platform such as mainframe emulator or a specialized cloud service with minimal code change and keeping the logic but changing the infrastructure. So refactoring is that goes further, step further, like restructuring and cleaning up COBOL code, like splitting up very large programs into smaller manageable parts, improving the data access patterns, or even converting some parts into newer languages while preserving the behavior. Like these steps can reduce cost, improve the performance, and make the code easier to maintain without the risk of redesigning the entire business process at once. And that is finally the long-term goal in incrementally retire or replace modules over the time. So the message is clear that modern COBOL strategy is not burn it all down and start again, but modernize and integrate. So that wraps you here with rehost, refactor, and where it makes sense. And then chip away the monolith in the small and win control steps. So that was about the uh, section. And this is what is basically the approaches. So yeah, and so this is basically it about the idea of COBOL. And yeah, I hope you got some inputs and ideas about how to basically um, work with any COBOL based systems. So here now we're open to your queries or your doubts or any inputs you may have through the chat. So you are free